Hey everyone, we're in the classroom for this lecture. I'm not going to use the whole board because I'm afraid if I do use the whole board that it will be too small for you. So I'm just going to focus on this middle board, but let's go ahead and look at 1.3. So again, if you are fresh out of an algebra class, this is probably a review, but just getting us all back on the same page, it's kind of nice to start out slow in that case and give people a chance to catch up if they need to. So we are going to look at 1.3, which is functions. And if you noticed, we're skipping 1.2, and the reason why is we really don't need to discuss in depth what is in 1.2. So really what we need to know is that 1.2 was all about relations. So before we define a function, we're going to define a relation. So we say a relation is any set of ordered pairs or it can also be written as any x, y equation. So for some oddball reason, they start teaching you this with ordered pairs rather than an equation, so we'll do what they do. So they're saying that we could have ordered pairs, like x, y ordered pairs, like maybe we have the ordered pair 1, 2, we have another one, 3, -7, 6, 4, 1, 7, 2, 8. Okay. And that would be a relation. It's just a set of x, y points. Now, you can kind of maybe see why we don't really necessarily need to spend too much time on that because that's not the way we normally see things. But it can be written this way, or it can be written as an ordered pair, or sorry, as an equation. So we could see something like y equals 2x plus 6. So x, y in an equation. We could see something uglier like x squared plus 3x y cubed equals 7. Okay. As long as it has x's and y's in it, it doesn't really matter what the arrangement is. That's going to be a relation. Okay, so basically any equation with x and y that you could graph is a relation. But we're not so focused on that. What we want are the relations that are specifically functions. So we say a relation in which each x coordinate corresponds to exactly one y coordinate is called a function. It's called a function. All right, so what is important here is that when you're given an x coordinate, that there is only one y coordinate that corresponds to that. So in other words, if I tell you what x is, you can immediately tell me what y is. And so coming back over here to our relation, the first one that we wrote out with the x, y points, in this case, if I told you that x is 1, so if I said, so using this guy, if I said x equals 1, I'm interested in what y would equal. Now there's a little bit of a problem here because right off the bat, we have 1 corresponding to 2, but a little bit further down, we also have 1 corresponding to 7. So the answer here would be 2, 2, or 7. Well, that doesn't follow what we've got going on here. That means that when I tell you what the x is, there's more than one y coordinate. So in this case, this guy here, while it's a relation, this is not a function. Okay, so this one is not a function. And it only has to fail one time. So what I mean by that is, like, if I told you that my x value was 3, you could immediately say, oh, well, the y is -7. So that one works. I tell you 3, you know the answer, but it only has to fail one time. So the fact that the 1 goes to 2 different places, that's our problem going on there. Now, I totally made this ugly guy down here up, so we're not going to deal with that one. But let's deal with our little y equals 2x plus 6 example. So if I said in this case that x equals, let's go with 2, so I give you the x coordinate. As soon as I give you the x, we have to do a little bit of work here, but can you plug this in and tell me what the y is equal to? So as soon as I give you the x, you can say y equals 2 times 2 plus 6, so 4 plus 6, so y equals 10. So it might take a little bit of math to get there, but as soon as I give you an x, there is one y coordinate that goes with that. All right, now, like I said, that last one's a little bit on the ugly side. So let me put up one that's not quite so ugly as that. Oh, let me use a different eraser, sorry. So let's say that I gave you just a relation that looked like x squared plus y squared equals 7. Now on this one, I want to know whether this is a function. So is this a function? And again, what that means is that if I give you one x coordinate, one x value, you should be able, with a little bit of math, be able to tell me what the y answer is. And there should only be one. So let's make our life easy here and just say, let's let x equal 1. So we're going to do the same thing we did down there by just plugging in 1. So we'll say 1 squared plus y squared equals 7. So we'll have y squared equals 6, right? Subtract the 1. And now we need to take the square root, don't we? So if we take the square root of both sides, we're going to get y equals, but when we take the square root, do you remember that we're supposed to put plus or minus in the front? And when we do that, we end up with plus or minus the square root of 6. Well, here's a problem, because that's 2 answers, isn't it? It's plus the square root of 6 and minus the square root of 6. So there are 2 answers here. So I give you the x value, but unfortunately, you cannot tell me exactly what the y value is because there are 2 different options. So that means that this guy is not a function. It's still a relation, but it's not a function. Right, so given an x value, there should be one and only one y value that goes along with it. Now this is one way to check to see if we have functions, but we're also, as well as seeing equations given to us, we might have to do this graphically. So when we do this graphically, we can tell whether or not graphs are relations or functions. So let's look at this graphically then. And when we look at this graphically, what we're going to talk about is the vertical line test. Okay, the vertical line test. And the vertical line test says if no vertical line crosses the graph of a relation, more than once, the relation is a function. Now, another thing that happens in math whenever we use a rule or a theorem or anything like that, somewhere along the line it had to be proved. We can't just make up things and say, let's assume that's true. It has to be proved. And when you do a proof in math, it's a lot easier to show that something doesn't happen than to show that it always does happen. So what happens here is we get a lot of definitions that are written in the negative. So this one says, if no vertical line. So instead of telling us what we want, they're actually telling us what we don't want. So what we're really looking for here is that if we draw a graph and we run vertical lines through it, if it crosses either 0 or 1 time, that's good. It cannot cross more than once. Okay, it cannot cross more than once. So 0 or 1 crossing is okay. All right, so just some sketches here. Let's say that we had this graph. Now, this goes for any vertical line. So if we take a vertical line over here and we just run it down through the graph, this vertical line is crossing the graph 0 times. That's okay, that's fine. So, but the problem is that this works for all of the vertical lines that we can have. So if we come over here though, and we drop a vertical line down through the graph, this vertical line crosses 2 times. And since it crosses 2 times, that means that this graph is not a function, it's a relation. Sorry, of course, now they're mowing the lawn outside. It's, that's just the way things go. So before it was peeping geese and dogs and whatnot, and now it's mowing the lawn. So this is not a function. But let's say that we had the graph that looks something like this guy. If we drop vertical lines down through this guy, any vertical line that we drop crosses the graph 1 time. This vertical line over here crosses the graph 1 time. This vertical line over here crosses the graph 1 time. And the arrow pointing this way shows that it should go on forever and ever in both directions. But looking at the shape of this graph, every time we drop a vertical line through it, it's going to cross only 1 time, and that's okay. So this is a function. So this guy is a function. So sometimes we might be given a graph without the equation, and if that's the case, then we can use the vertical line test rather than plugging in numbers. We use the vertical line test and tell real quick whether we've got a function or not. Okay. Sound good there? Now, the next thing that we want to talk about when it comes to functions is what we call domain and range. And again, this may be review for you, but I'm telling you now that domain specifically, but domain and range become very important in calculus. Okay, domain is a really big deal. So we're going to talk about domain and range. Okay, and the domain is the set of all first coordinates in a function. Now, it's written this way as being the set of all first coordinates because it's being very broad, but for us, normally that's the x values, okay? Because our points normally go x, y, right? So the first coordinate is normally the x, so that is our domain, and the range is the set of all second coordinates in a function. And for us, normally the second coordinate is the y value. So normally that looks like x, y there. Okay, so the domain is all of the x values that you can use in a function, and the range is all of the y values, the answers that will pop out. So let's just start with our basic line. So let's say that we just had, I can't even remember what I wrote down there just a second ago, but let's say we had y equals 2x plus 6. So the question is, what x values can we plug in to this function? And so basically we're asking ourselves, what values can we multiply by 2? And truly, we can multiply any number by 2, right? We could plug in 0, we can plug in 6, we could plug in pi, we can multiply anything by 2. So the domain here is all real numbers. So all of the values work here. And if you want to see this in interval notation, it's negative infinity to positive infinity. Okay, negative infinity to positive infinity. All the numbers work here. Now, likewise, if we can plug in any number to this line, then we're going to get all real numbers coming out of this line. Now, that won't always be the case, but when you're dealing with a line, you've got a nice domain and range. But let's look at another one that doesn't quite work that way. So what if we had y equals, and let's just go easy here and say x squared. Okay, y equals x squared. Now, we're only interested right now in just what's the domain and the range. So we'll say domain. And basically, we want to know what numbers can you stick in there and square them. And really, you can square any number, can't you? You can plug any number in there and square it. So this, again, is all real numbers. Okay, so that's looking like it's starting to be a trend here, okay, all real numbers. But now we need to think a little bit. For the range on this one, you can plug anything in there and square it. But when you square something, the answer is always going to pop out and be positive, isn't it? So if you square negative 2, you don't get a negative answer, do you? Negative 2 gives you positive 4. Negative 10 gives you positive 100. So even when you stick in negative values here, you're only still getting positives. So your range is not all real numbers this time. Your range is only the positive values. Now again, interval notation means that we're going to start at 0 and go positive, which means go to infinity. Now the question is, do we get 0 as an answer? And yeah, if you put 0 in here and square it, you do get 0. So this is going to be a bracket 0 to infinity. Okay, so because of what the function does, the range changes here. Still plug in all real numbers, but the range changes. Okay, let's just look at 2 more and then we can be done with this. But I promise you, domain and range will come back again and again and again and again and again. So let's say that we had y equals 1 over x squared plus 4x minus 5. So now what we need to think about is what type of numbers can we plug into a fraction. And normally, honestly, when we're dealing with the fractions, we're not going to focus on the range. I'm just going to ask you about the domain in this one. We'll deal with fractions in I think chapter 2, but anyway, we'll deal with fractions a little bit more. So we're just focusing on the domain here. But don't we know that the denominator cannot be 0? So if we're interested in the domain, basically we're plugging in values for x, but these values for x are in the denominator. So there might be a couple values that make the denominator equal to 0. So what we need to do is take our denominator and figure out where it equals 0, and those are going to be the problem places. Okay, so we've got a quadratic here, so we're bringing back the idea of factoring. So if we factored this guy out, that x is up front, two numbers that multiply to be 5 are just going to be 5 and 1. And we need it to be a plus 4, so it'll be a plus 5 and a minus 1, and that gets us our minus 5 in the end. So here we get x is equal to negative 5, and over here we get x is equal to positive 1. But those are the places where we're going to have the problem. So the truth is that we don't want negative 5 or 1. So x can't equal negative 5 or 1. So that's our domain. So our domain is, you can use all real numbers except negative 5 or 1. So we can write that as all real numbers except negative 5 and 1. Okay, so and again, like I said, not really going to focus on the range on that one. Okay, we'll deal with that a little later. Let's do one more here. Y equals the square root of x minus 4. All right, so now on this guy, if we're interested in the domain, that x is underneath the square root. And since the x is underneath the square root, we are going to have some issues with it. We're staying in the real world, so we're not getting into imaginaries, okay? So we need that to be positive, don't we? Okay, we need that to be positive. Now, could it be 0? Can you plug a 0 underneath the square root? Sure, the square root of 0 is 0, but I can't plug any negatives. So here our domain is going to be limited. It's going to be 0 to infinity. So including 0 and then all the positive numbers. Now in this one's not so hard to find the range, so we'll go ahead and find the range on this guy as well. Let's say that you plug in all of those numbers 0 to infinity. What's going to pop out? Don't worry about the minus 4 right now. What's going to pop out? Okay. You're not going to get any negative answers, are you? Your answers are all going to be 0 to infinity. Okay? So the answers here are going to start as 0 to infinity. Okay? Now notice I'm writing it here because this is kind of our scratch work down here. We're still thinking about what's going to happen. So positive answers are going to pop out of here, but then what are we going to do to every single answer? We're going to subtract 4, aren't we? So even though the range of just this part would be 0 to infinity, we're going to subtract 4 and subtract 4 to every single value. So that puts us at negative 4, and then infinity minus 4 is honestly still just infinity. Okay. So our range ends up being negative 4 to infinity. All right, so domain and range, and again, most specifically domain, we'll talk about quite a bit. All right, so that is the intro to functions. We'll continue on in 1.4 with more function stuff, but there we go, okay? All righty.